Sam, take your headphones out. So in terms of these two here, the two in front of the sign, so again, sine of theta, sine of x, same thing. They're just talking about an angle x versus theta, just two different variables. The two, what does the two stand for in this example two? What's that? The amplitude. So this one's talking about the amplitude is 2. What's the period going to be then in this case? What's the period going to be? Yeah. That wasn't right. It wasn't a hand. It's going to be 2 pi because the b value is what? 1. The b value is 1. So it's 2 pi over 1. So the period doesn't change. It's our typical period in this case. The amplitude is 2 though. So they have the nice like tick marks already for me. So now this time, just like a normal sine graph, it's going to start at 0, like sine would typically, but then it's going to go up to 2 and down to -2. So as I do this, I start at 0, 0. But by the time I get back to this point, I should be back at 0 again. My halfway point should also be 0, but it's going to go up to 2 and down to -2. So we have our graph, and again, when you guys draw this, try to draw it as a curve rather than straight lines. But obviously, sometimes it looks better than others, depending on just how it goes. So our next one, all they did was move where the 2 is. But again, if you're thinking back to regular lines, if you moved the 2 in a y equals mx plus b equation, if it was front of the x or versus at the end being added or subtracted, it would change this quite a bit. So it does change it a lot. So our a value in this case is what this time? It's only 1. So the amplitude is just going to be 1. So this one's going to be a shorter graph than, like, in terms of height. But now the b value is what? B is 2, which means when I go to find the period, you do 2 pi divided by 2. So that's just going to be pi. So that means it's going to do a full cycle revolution before we get back to pi again. So this is going to be a little bit tougher to draw, and so I'm going to suggest you kind of make sure you're following along with this. I think some of you guys have gotten it already. So you basically should, it's going to be like double as fast in terms of the last one. So the way I try to think about it is I try to use my typical graph or like my unit circle to help me with it. So when I do this, I know it starts at 0 still, but by the time I get back to pi, I should be done. So this whole graph should repeat before I get back to pi. So then I find the middle spot. That should also be 0. And then in between those two, it's going to go up to 1 and down to 1. So this one's kind of weird because it like, I'm just going to kind of go in between. So it repeats completely by the time it gets back to pi. But then it would do that again. So if you'd want to draw it again, by the time it'd be at 2 pi, it would have repeated again already. So this one happens more frequently. This sine graph is working out faster. Okay. So we're going to change some other things about this. We're going to actually talk about sine. Oh, so it asks about similarities and differences. So kind of going back to similarities, still talking about, I think it was Anna that said like, it still goes like 0, 1, 0, -1. That pattern still continues, that we still just do that same pattern, that we go 0, 1, 0, -1, 0. That still doesn't change. Like that pattern still happened. The difference is that it happened faster, or it could be taller or shorter. So kind of just in short, like the A and B were different. But it still started in the same place, ended in the same place. It just had the same maximum and minimum. So now we're going to talk about a cosine graph. So our next one's asking us for the cosine of 1/2 x. And we apply all the same rules. We just have to remember our cosine graph is slightly different than our sine graph. Because that one doesn't start at 0. Cosine should start at 1. So just remembering that already going into this. So cosine starts at 1 and ends at 1 and goes down to -1. It's kind of like an important thing to be aware of as we do this. But the amplitude and period all still work the same. So what's my amplitude for this one? 1. Just the 1 in front of the cosine. And now this one, the period, the b value is 1/2. So we had talked about one like this already. So it's 2 pi over 1/2, which really just becomes 4 pi. Okay. All right, now this graph doesn't give us the nice little markers, and sometimes that's good and sometimes that's bad, because like the 4 pi wouldn't have, well, I guess it would have fit on the graphs we had, but if we got more than that, it would be tougher. So we're gonna have to try and draw these graphs and kind of do some of the markings ourselves. Now I want to get to 4 pi. So I'd like it to be where I think every other, if this goes pi, 2 pi, 3 pi, 4 pi, that should work. I want to make sure I get that full revolution in, so I'm trying to be kind of wise about my spacing. And then the other ones are going to be halves, so this would be pi over 2, 3 pi over 2. If I don't need to mark them, I don't need to, it doesn't really matter. So where does cosine start?
At 1.
At 1. So cosine's going to start at 1. Do you want to make just this line here 1 and this -1? Yeah, okay. So 1 and -1. So it starts up at 1. So I'm going to put a dot there. And it needs to end back at 1 as well. So by the time it gets back to 4 pi, it's going to be back here at 1 again. Does that make sense? Now where's the middle going to be? 2 pi. And where's the amplitude be at that point?
Negative.
Well, but yeah, it's technically the amplitude is 1, but it'd be down 1, right? Because it goes down in between. And then in between those 2 points, where is it going to be? 0, right? So this might be something that's worth mentioning or like writing down somewhere. That we said like the sine pattern went 0, 1, 0, -1, 0. Cosine starts at 1, goes, I should use like an arrow instead of otherwise that looks like a negative. Starts at 0, or starts at 1, goes 0, -1, 0, 1. So that same pattern repeats again and again. And so just being comfortable with that pattern repeating. So this one, again, we're going to want to make it into a curve as best we can. But this is a pretty long, slow, like cosine graph versus repeating twice in that amount of time. Okay? Now, sometimes I'll ask you guys to do this, depending on what's going on there. Depending on the situation, I might ask you guys to graph. It says graph at least 2 cycles of the function. So that means like the last one, that wouldn't have been 2 cycles, that would have just been 1. That would have been a hard one to fit 2 cycles on there. Typically I'll do that especially when they're shorter. It's kind of a hint a lot of times that they're shorter. So see if you guys can figure out this sine of 4 pi. Or sine of 4x, sorry, I said 4 pi. Just here to confuse you.